Hey guys, what's up? This is InvernaBoy16, and today I'm doing a video on what could possibly be one of the smartest computer fans that I've ever come encountered with, or encounter with. This is probably one of the most intelligently made or designed fans for consumer-grade computers, which is what I got this out of. It was an old computer that I found in the trash. But this fan is made by NMBT, MAT, which I'm not really sure what that stands for or what company that is. I've never heard of them before. I'm surprised Delta or Aerocool hasn't made a fan like this, because this fan, you'll see here shortly, is probably one of the most intelligent fans for a computer that I've ever seen. And I'll get more into that once I actually start doing the running it and showing you what it does. Well, that's so cool. First thing you can notice that'll actually set it apart from other fans is that it's not a regular fan where it just has the blades that shoot straight through the casing. This one is actually what is known as a squirrel cage fan, where it sucks air in through one way and then directs it through a different. It's sort of like an elbow joint in piping. If you work with like tubing or plumbing or whatever, it does the same thing but for airflow. But the thing is, the reason that they used this fan is the squirrel cage fans are a lot more efficient in the movement of air because they have a much higher surface area of blades. If you can kind of see in there, each one of those little ridges in there is about a centimeter thick blade, or not thick but wide blade. And if you were to build a conventional computer fan like that, it would have to have around 40 blades to be able to have the same amount of blades that this has. But this allows for you to fit a huge amount of surface area in such a small little thing and still make it to be functional and operate well. Another thing that's kind of odd about this fan is it does use a lot of power. 2.6 amps at peak power draw, which is, in the computer world, a lot for a fan. Normally you draw about 0.2 or 0.5 amps, but this one draws 2.6, I mean 2.5 or whatever. And the reason that is because this creates so much air pressure and suction that it drags the motor inside. But it has a brain in here that controls that as well. But I'll first show you what it'll do. This is just a control board. It's just a voltage regulator or whatever, sort of like a multiple voltage power supply. But if those of you have seen the video that I've done on this, you'll know what I mean by that. But I'm going to set the voltage to 12 volts, which is what this fan is rated for. Let's go a little bit over, 12.1. And then watch what happens to this fan whenever I start it up, or listen to what happens to it, because you can't see the blades because they're underneath where the heat block is, or the heat exchange block is. So listen to it whenever it starts up. You'll hear something pretty interesting. So I don't know if you heard that, but if you did hear it, you would have noticed that it started up like as if it were normal, and then it stopped, paused for a sec, and dropped down, and then rose back up, came back up. And what it's doing, and the reason it does that, is because this fan has a Hall effect sensor in it. For those of you who are not technically minded or don't know what that is, a Hall effect sensor is something that allows you to track the speed of something. Your cars have those in order to be able to tell you what your speed is on your speedometer. That's what a Hall effect sensor is. sort of like, except in a car you don't use a Hall effect sensor, you use a, I'm not really sure what it is, but it's sort of like a Hall effect sensor. What all a Hall effect sensor is a magnet on a wheel or on a rotating drum or whatever, a shaft or whatever it might be, and then it has a little electromagnet pretty much, that picks up the magnetic pulse and sends the pulse to a computer. Not a computer like this, but a computer that can tell what speed it is by reading the different frequencies of the RPMs of the fan based off of the magnetic pulses that it gets from the accumulator inside, which the accumulator is that little electromagnet that picks up the pulse, sends it electronically to the computer, and then the computer tells what the unit is doing. But that's pretty much what this has inside of it. And the reason it has that is because if you go above, with this fan, if it goes above a certain speed, when this catastrophically fails, it will shoot parts out of it, because there's nowhere else for it to go except through here. And then it could end up, even if it's a computer, because of the RPM that this fan gets up to, it could shoot the blades out and then damage the computer. And plus, you don't want that to happen to a fan like this, because this is an expensive fan, I would imagine. Probably, I don't know, at least $50 for this for the whole unit, for the heatsink block and the fan itself, but I'm not really sure. But the reason it has that is to track the speed, to be able to monitor it, so it doesn't over rev and then damage the fan or catastrophically fail, like what I just mentioned. And another reason it has that is because the computers that are capable of it actually have the ability to pick up those magnetic senses, in which is what these two wires are here, this blue and this white one are. The black and red are just your positive and negative. Those two wires go to your power consumption, or one wire is for power consumption, and then the other is your Hall effect sensor. So your computer can talk to this fan as well, and your computer can make adjustments to the fan. But when you're just running this off of a basic power supply or a computer that doesn't have that capability, this has that computer already in it. So that controls it as well. But what I'll show you now is what happens when you're on a lower end of power. So I'll take this down to around 5 volts, which is another voltage that is commonly used in computers or desktops. Let's just put it 5.2. So watch what happens this time, or listen to it. I'm not sure how well you'll hear this, but watch what happens to it, and I'll put this on the power consumption, and you'll see what happens to it when it's running. So we'll start it up. Okay, just wanted to wait for the clock to finish there, but for those of you who were paying attention the whole time, or didn't hear it, but could see, the amperage, which this is not what it used, this is just what I have the board set to for its maximum output, you could see that the amperage started off very low, like 0.2 or 0.02, and then it would slowly ramp up. And the reason that this does that is because 5-volt circuits can only put out 2 amps maximum on most common desktops. And the reason they do that is because if you were to draw anything more than that, you could melt wires and stuff like that on your PCB board and other things. So the reason that this fan starts up so slowly is to not overheat those wires or components. And you saw it only went up to 0.4 amps, which is a common use for circuits running off of 5 volts on a computer. So this fan knows that you're putting in a very, very fragile voltage that if amperage was drawn over a certain point, it would destroy parts of the computer. So that's another thing that this fan has that's really cool about it. And you could see how slowly it ramped up. So that's to protect the 5-volt circuits on the fan on the computer, because whenever your computer switches over into sleep mode or into low idle, the fan does that in order to conserve energy. It lowers the RPM depending on the temperature of the motherboard or the CPU, which is what this block connects to. And then that block just exchanges the heat on these metal fins, sort of like a radiator in your car. And then the fan sucks off that heat and then spits it out. But the thing is, when your computer switches over to that low idle mode, it's pumping in 5 volts coming from the power supply through the cables on here. So the fan knows that. And then if you were to start up off of that low voltage, it would want to gently ramp up. It wouldn't want to just immediately be at full 5 volts, because that could cause a power surge and damage different parts of the computer. I'm going to show you one last thing that I think is really cool about this, though. And that is the voltage overramping. So this will be if you have too much voltage going to your fan, going to this, and then I'll show you what this will do to prevent problems. Alright, let's go to voltage. We'll start it at probably 10 volts. That's probably where it runs normally on a fan. This fan would run itself at normally, or the computer would have it set to. 12 volts is really the maximum that the computer would put out, and that's when the CPU is really hot, or in some cases overheating. Hang on a sec, what is that making that noise? There you go. Alrighty, so we're running at 10 volts. Watch what happens when I get above 12 volts. Alright, so if you noticed there, once I got to 12 volts, I went up. It revved up a little bit, but once I got to around 14 volts, it immediately brought the fan's RPM back down to where it was when it was at 12 volts. And if you noticed, as I was dropping down from 14 volts back down to 12, the fan did not change its RPM. So that's the over-revving protection that this fan has. So this makes you think, if they're making fans that are this intelligent for computers, why not make them for households or personal fans as well, or AC units? Because this type of ingenuity and brain or artificial intelligence for a fan is quite out of this world if you consider it. But anyway, I just wanted to show you guys this video, or share this with you, because I think this is really cool and shows you just how far we've gone in technological advances for something as basic as a fan to be that smart. So, anyway, I hope you guys enjoyed. Please don't forget to comment, like, and subscribe, and I'll see you guys later. Stay cool, YouTube. Bye.